Hello everyone. In this episode, we're going to talk about the LangChain data extraction, about the basics about it. Okay, let me go to the code. So here is the code. Okay, so we'll do the usual thing. We check its Go Colab and then have the secret key, OpenAI. As you understand, here is my API access key stored. And then we are going to load a couple of libraries that we need for this. Okay. So what LangChain can do is that it has a nice feature about the output parser in that when we ask ChatGPT or other large language model, LangChain allows us to basically parse that returned answers from the LLM and have it output in certain format. Okay. So there are a whole lot of them here that they do. But first, let's see a structured output parser. Okay. So here, it's very useful when you want to return several fields in a certain way. I guess a good example would be here. So here, for example, when we have return a model, then first is the answer for whatever answer you had, and then give me also where the answer came from, like the website of it. So there's an answer and the source field. So the output parser, like the Pydantic output parser in this particular case, is that we want this answer with a source, okay? And then can have a prompt template like here and the particular question. And for the output parser, for Pydantic output parser, get the format instructions of whatever that is here. All right. So let me just run the code here. Okay. So it's checking the key and load the files. Okay. All right. That's done now. And so now here, as I said, we want the answer and the source here as when the ChatGPT gives us model, we can have the LLM defined and then have this long chain, the chain, which is starting with the prompt to the LLM, and now it goes to the output parser, okay? And so we can have a question, okay? Uh, what shall we have? Let's say, who first derive okay, like this. Uh, so if we ask that, it keeps thinking. By the way, do you know this answer? It's Bill Sharp, Jan Mossin, and John Lintner. Oh, well, Jack Traynor. Okay, so he had a manuscript that was unpublished. Okay, so apparently it does know more than I do. I guess the other people were also there in 1964. Okay, and now we can construct a template that both the question and formatting instructions here. Answer the question as best as possible. And who derives European call option pricing model? Okay. And the answer goes here. And answer and type and string. So this is how the question would look like. Okay. And if you have LLM, And then let's see the answer of it. The European call option formula was derived by Fisher, Black, Myron, Schultz, and Bob Martin. Okay, and here is the source. I guess they got it from Wikipedia. Okay, so this is sort of what the output parser can do. It can do structured. It can also detect some language, for example, and then output in a translated language. For example, here, translation output, we have a class here, and then the detected is the language the user's input, and then Spanish, French, Chinese, okay? Um, so in the output parser is not translation output. Detect the language. So here, and then the question. We have an LLM, and then the chain of prompt LLM and parser, and um, well, just simply hello, how are you? Hopefully, some of you guys know this language. I don't quite. Uh, Comment ça va? Okay. Um, and then the question here. The European call option pricing model, it will detect which language it was, which is English, and then it answers, it translates into three different languages. All right, cool. All right, so the next one is a little bit more useful thing. So web source and translation is interesting, but oftentimes in finance and economics, we deal with particular data files like the CSV files, or JSON or pandas. So let's do this. So first the CSV file. So it's an output parser of comma separated list output parser. And who derived the European call option pricing model? Now it could give in any format if you don't specify it, but in this particular case, we want comma separated list. And let's see. So it basically gives in comma separated files. Okay. And Nobel laureates in economic sciences. Okay, so here. And major capital firm, something like this. How about the JSON response? So it's very similar. So you can detect the language and then translate it. Who derived the European call option and parser, and then JSON output parser. So, and then we give the prompt here and have a chain, and then it gives here as a JSON output, isn't it? Another useful thing is Panda. So we read a file here from Iris database. Okay, and I want the column and data here, and then have the uh, DF result as a data frame result. So the template here for the prompt is that you're given Iris dataset preview, and then table, return it as JSON specified format here. And give it in a LangChain. So we have it as a data and column, and then have it as a data frame. So here's the data frame you got. Now here, answer of the field, answer to try to query. So um, now here I have a parser of Pydantic output parser of this answer, basically to answer the query. Okay, so now we are going through the Panda data frame of the prompt of something like what is the average of each species, something like this. Then this output parser will basically go through this and have the averages, okay, or the mean of a particular column. So that can be fairly useful. Okay. Another thing that's very useful is that it can actually capture the date and time in that output. Okay, so it's a date and time answer of the field, and here the date time answer is the parser that we'll use. So answer user's question, of this. So what date is the next leap day after 2025? And it will give out the answer. And you can see the prompt here. Yeah, the parse dates, and then when was Black and Scholes equation published in journal? It's 1973. Okay, so here it is. And when was CAPM theory first published? I think it was 1964. But you can see that it can capture there from the part just the answer of the time, daytime. Okay, so this was about how to extract data, some of the basics in LangChain feature. Thank you for watching this episode.